Okay.
Did we get hailed on going to class on Monday or Wednesday?
It was Wednesday, yeah.
Okay.
That was the day we got the lightning strike on the rooftop camera too. All right, I think we're ready to go.
Okay, welcome to our weather discussion for this week. Another exciting week. And it was the week before where we were 70 plus every day, and then this following week has been a lot different, entirely different, and with an intervening weekend where the transition occurred. So Saturday was pretty nice last week, but then Sunday was chilly, and the Sunday night into Monday, I think mostly Monday morning, we had that burst of snow, which was 2-ish inches at my house. I don't know what it was officially at the airport. I never bothered to look. Yeah, I bet it was close to 2, might have been more. And it was powdery too, which was really weird. So it was this kind of small flake dendritic snowstorm, which is much more characteristic of February and January than it is of April. It's just incredible. But maybe the 4th out of the last 5 Aprils where we've had measurable snow, and I mean more than an inch on one day. So just an amazing day. And then disappeared quickly when the sun came up, of course, even though it was chilly on Monday. And then Wednesday we had lightning, thunder, and overnight some rain, and then we had hail on Wednesday morning. And Posh reminded me it was Wednesday walking over to class. We got pummeled by these little pea-sized hailstones, and that was pretty interesting. So, and then yesterday was also an interesting day in the sense, as Ian points out, it started out kind of chilly, and then when the sun finally came out, it was 69 degrees, 70 degrees or something. It was just incredible with a dew point around 50. So remarkably transient kind of weather. I think it testifies to the fact that the sun angle is really high now. I mean, we're on the 21st of April now, and that's the equivalent of August 21st. So, one doesn't often think about it that way, but that's exactly equivalent because we're 2 months from the solstice, and that's 2+. So August 21st is not notoriously cold and clammy. It's kind of just the opposite. You're kind of wishing the summer could go on a little longer because it's usually pretty nice. So as soon as the sun comes out on any of these days, it almost doesn't matter what air temperature is aloft. You're going to get a little bit warmer. What does matter is if it's too cold aloft, you get cloudy. And I think that's going to be the threat for the weekend with the invasion of a cold air mass in the wake of this cyclone, which is really quite an intense disturbance. Well, not intense in sea level pressure, but intense in terms of sensible weather that it delivered. Yesterday's storm reports all the way from just, I think maybe one hail report in southern Wisconsin, maybe near Janesville. Everything else was from Chicago down past Dallas. Fairly substantial hail reports. Some high wind reports, one tornado in Tyler, Texas, which is right outside Dallas, I think, right? So there was a tornado there yesterday. Some fatalities, amazingly, and it was the only one. And we had widespread watches across the central U.S., including close to us. So it was a day of reckoning, but much of the tornadic activity didn't come to pass, thankfully, but a lot of hail. And today, we'll see in a minute, a lot of precipitation. I think it's beginning to become convective on the southern end of this a little bit, maybe more so offshore, which we can't really see as well with the radar. It doesn't go quite that far south. But we'll see precipitation along this fairly elongated cold front. The wide cloud swath associated with the warm front is back in here over Ontario and parts of Quebec, and then light snows, scattered snows over the Dakotas and Minnesota on the cold side back in the included sector of the storm. And you can see also, we saw this last Friday, some really beautiful daytime cumulus clouds developing on the coast of South Carolina, the entire peninsula of Florida, and even the Yucatan. And then they get blown off. There's some smoke too maybe that's involved in there, but much of that's cloudiness that happens down here near the Isthmus of Panama as well. So it's a lot of different daytime, very rapid development of low-level cumulus clouds for daytime heating. So pretty nice. Really quite an insightful satellite picture today. Okay, so let's take a look at the upper level of the radar first, Pete. So here's that lengthy line of precipitation. It stretches, of course, into Ontario, as we saw. It's getting speckled with convective elements down over Arkansas, Mississippi, parts of western Tennessee. But as I suspected, maybe this stuff here, you get a little glimpse of it, and then it goes out of the radar range. This is probably a little bit more convective, this complex-looking thing at the end of the front, south of Louisiana. And then this is all the swirling light snows. We'll take a look at the observations in a minute to see if we can find some stations. But you'll certainly will find some. Rather persistent precipitation in the lee of the Black Hills. That might be orographically linked a little bit. And then this is mostly snow. Maybe some of these places with a little bit higher reflectivity are warm enough where it's raining. That might be what differentiates the look and the reflectivity. the circulation center is over central Minnesota. And so before we go to the upper levels, let's take a look at that surface map that you were about to get to, because this is really the only game in town this week, this Friday. Okay, so let's take a look at our own region first, see where it might be snowing. So light snow, even in La Crosse, so light snow in La Crosse, light snow across central Minnesota, and a couple of places it's light rain in North Dakota, but broadly speaking, light snow, heavy snow, is that Sioux Falls? Heavy snow at this particular location, so that's interesting. And then, but as I say, widespread light snow, temperatures mostly at or above freezing, but dew points just a degree or two below, so this is the kind of snow that's barely keeping the column cold enough to stay as snow. And then we're in the sunshine, even though it feels chilly, 53 isn't terrible. In a 29 dew point, it's bone dry, the sky is crystal clear in blue skies. And then you can see the precipitation ranging all the way from, well, it's off the map in sort of central Ontario, down across Lake Huron, western northwest Akron, and then down heavier rain in Terre Haute, and some rain even as far south as Hot Springs, Arkansas. So it's maybe even further south, I bet. So, let's see. No, that's the last reported rain observation, but there's probably some off the coast. It's thunderstorm at New Orleans, with a dew point of 66, so that's pretty super. And in the eastern United States, very warm temperatures, but dew point depressions 15 to 20 degrees, not so bad, sometimes 30 degrees. So in Philadelphia, my wife's there right now, 72 over 54, that's not hard to take. 50 over 38 with an east wind in Boston. You can't get near the Atlantic Ocean and expect a nice day even though it's sunny, that's miserable. The other day was the Boston Marathon, and they had the Patriots Day game at Fenway Park, which starts at 11 o'clock. It's the only early game of the year, really. And notoriously a miserable day to be out at the ballpark, because it's usually an east wind and you're freezing. It's 50 degrees in the sun, so it's 42 in the shade, which is most of that old ballpark. And the team is 500, so it's not worth going. Whereas if there were no roof at Milwaukee and you want to see the Red Sox, that's against a team that's 15-3 or whatever they are, 14-5. They're having a great start to the season, and they ought to mow down the Bo Sox without too much trouble. So I'm looking forward to that. I'm going Saturday night. Sorry, Bella. I don't hate the Red Sox, but I live in Milwaukee, so yeah. Well, Peralta's going to win tonight. There's no doubt about that. So, and then after that, Brewers have won every series but one this year. So they're having a great season so far. See how Boca keeps going. All right, let's go to the upper level charts. Keeping in mind that our circulation center, the cyclone center, is over the arrowhead of Minnesota at the surface, and it's a little bit further to the west at upper levels. And here's this morning's 7 a.m. map, and boy, it's right on target. So there's the center of the cyclone at 500 millibars, again, right over the arrowhead. So this thing's about equivalent barotropic right now. And there's a pretty decent temperature contrast associated with the cold front at 500 millibars. It's displaced to the west. Remember, at the ground, it's kind of going along that line, and it's displaced further to the west at 500. But it's characterized by cold advection, which suddenly stops at the front edge of the baroclinic zone. So that's frontogenetic. And so it's probably a deep frontogenetic band along that. Maybe we'll take a look at, is it pivotal or tropical? We'll let you do cross-section. We'll do that in just a minute. But a kind of a broadly wavy flow in the middle of April here. This is the big disturbance in the central part of the United States. It was just like this earlier this week. We had one that took a long time to get out. And so here's the big trough across the central U.S., and then a ridge over the eastern United States, and then a subsequent trough downstream. This one is associated with, I think, a pretty decent development in the middle Atlantic. And then I was intrigued earlier. I think the 0Z map had this baroclinic zone extending further to the south and east. But it's very intense in the analysis right off the British Columbia coast. That's 10 degrees at 500 millibars over that short little distance. Seems exaggerated. But it is these are the breeding grounds in northwesterly flow for these strong upper fronts, which, if they find their way southeastward in this northwesterly flow, can just continue to pump this thing into a more or less a stationary feature for a couple of days. And we'll see if that's in the forecast. I don't know. Patrick's going to tell us a little bit about the forecast. But I do know, broadly speaking, the weekend is not going to be very nice, and so maybe that's one of the reasons that lies behind that. Temperatures at 500 millibars are pretty chilly in the core of this cold air. Minus 28 at near Minneapolis, minus 28 in North Platte, minus 27 near Omaha. So that's pretty chilly air. And that, to the extent that that doesn't get dislodged very quickly, that presents a problem because the ground warms up fairly fast with April sunshine. And if you're only 5 kilometers above the ground and your temperature's minus 28 and you're at plus 10 at the surface, you're running a lapse rate of about 8.5 or so degrees per kilometer, which is, if it's saturated, it's absolutely unstable. So you're going to have the development of cumulus cloud underneath that cold dome. So that might be our fate for the weekend. Let's take a look at the 300 millibar chart, Pete, if we could. And so you get a picture of the jet structure at 300 millibars. Fairly absent on this map is any suggestion at all of a subtropical jet. Perhaps this is the one exception. But there's a really strong polar jet in the northwesterly flow over the western United States, the Rocky Mountain region. And then we got 165 knots here at Green Bay. That's the maximum wind speed in this jet. And that's a fairly intense straight jet across the central plains of the United States. And then downstream there's some curvature. So this is a pretty decent place for ascent, right in this location, and that's where the cyclone is kind of circulating around. Aside from that, this is the next feature in the wavy flow that's strongly and jet-like south of Newfoundland. That's tied to a cyclone that's out here in the cyclone land. Nothing obvious anyway upstream, but we have a limited perspective there. Can we go to 200 millibars to see whether or not these jets at 300 get weaker and we see anything appear at southern latitudes, which we do. Boy, isn't that nice? So these jet structures are the remnants at 200 millibars of the core that exists somewhere in closer to 300. The same is true over here. So these are polar jet segments. We saw almost nothing of this subtropical jet at 300 millibars, except perhaps for this little patch down over Texas, which is the underbelly of the overlying subtropical jet. So this is a really interesting broad-scale cyclonic shear imposed on this whole structure by the presence of the subtropical jet with this vigor over Mexico and the adjacent waters on either side. So how that shear, and what I mean by shear, I mean it's just horizontal shear. You're putting a spin on this whole higher latitude feature that's cyclonic. Does that tend to intensify and prolong the cyclonic nature of the flow in this part of the country, or does it have no effect at all? Kind of an interesting question to pursue. And we might see some evidence one way or the other for this particular evolution over the next couple of days. So I know we've got a presentation about a recent chase. So I'm done with the current weather, and Patrick will take the forecast, but then I want to turn it over to Bella and Layla and maybe compatriots, I don't know who else, and come on in and tell us about your chase. Perfect, great. And you can use the pointer.
Can you go to pivotal weather, please? And can we go just to home? And we'll scroll down here. Can we below this enlarge this? Perfect. So here's a look at the current hazards. This is way more comprehensive than weather.gov, which you can't zoom into. But we have freeze warnings over my home city of Lincoln and into Iowa and existing portions. The winter weather advisories for the snow and wind advisories for the storm system moving up in northern Minnesota. And then you can see some lingering winter weather advisories out west due to the cold air. But that's really the main thing going on. The entire eastern portion of the United States for now is relatively watch and warning free at this time. So this is our main player. So we can look at where is this thing going to move and what is it going to do when it moves. So could we go to our AOS page with the loopers? Perfect. And then let's go to the surface with total precip one, right? And could we go, we can just let this play, but could we click it slower?
Just because it goes up to 71 hours right now.
Okay, we could go back to the 0Z one if you want. That's the one I was looking at today. Sure. Please. So this is a loop of sea level pressure, and then in the colors will be the total precip from the GFS. And we'll just play this really slowly. First I want to point out, just look at the colors. I'll let this play a couple times. Colors will tell you where there's going to be a lot of liquid precipitation. And so once this loops again, we can see here's our cold front and the storm system. It tracks over into Canada and leaves a trail of precipitation. There's an interesting little feature that moves off of Texas that is a little suspect, and I'll point out why in a second. But you can see largely there's a lot of precipitation for the southeast United States. And we stay relatively precip free, which is nice here. But unfortunately, that usually means just clouds for us, not necessarily sunshine. So we'll let this loop again. We can see here's our system moving off. Right here, there's a very small cyclonic disturbance that moves, but produces up to 4 inches of precipitation just off the coast. So that's why I think it's a little suspect. I don't quite know if that's going to verify. There's not really any feature tied to what or how that develops and moves. But what is not suspect is all of this heavy precipitation over the southeastern United States, and especially I want to point out Kansas and Oklahoma, where precip totals get into the 3 and 4 inch range. So I'll let this play once more. So we can look at why is this precipitation, this broad region of heavy precipitation going to persist, and why am I pointing out Kansas and Oklahoma specifically? So we could go back, just exit out of this, please, and we'll go to the surface and 3-hour precip now, and we can stop it. Please, and then we'll go to current times, so around 18 UTC, please. So this is a look of last night's GFS model run. Here it does a great position of where the low pressure is actually located. This cold front is spot on. There was a heavy band of precipitation, and especially off the coast of Louisiana. And then here's our wraparound snow, and you can see all these cold thicknesses exactly where they are. So this is a great verification. If you could just step forward, please, Pete, very slowly. We'll just watch this storm system. It lingers, and then it moves off into Canada, and you can see this cold air just persists behind the low pressure system. We can just keep going. Here's maybe the inkling of something developing off of Texas. There's heavy precipitation. If we keep going, we'll notice it just develops right off the coast, and there's a very tight cyclonic disturbance. I'm not really sure what the minimum sea level pressure is, but very small scale. So that might just be an error in the model forecast or something like that. But you can notice as we keep going, we'll get into Tuesday, we're still largely cold, lower thicknesses, but then we notice a low pressure system begins to develop over New Mexico and western Texas and just sits there for a prolonged period of time before moving, and it will move across the southeast. And so you can see this color fill is our heavy precipitation that moves over the southeast, and we get those heavy precipitation totals that we saw in the loop before. And we stay dry, as noted in the QPF. So this is perfect. So we can go now, let's go back to just our, let's see, the 500 hectopascal map, please, and we can do the loop again. And we'll stop it. Okay, go back to about now, please. Thank you. And then we'll step forward. You can just keep clicking forward again as we did. So we'll notice here's our low heights, indication of cold air over us. We'll just watch this sort of persist over the weekend, over our region, and then we'll watch something over the west. Maybe a small shortwave begins to develop and moves over the southeast. You can notice there's not really a very strong signal for anything that would, explain 6 inches of precipitation over a wide region. You can see little pockets of of a very strongly positive relative vorticity in the color fill. But if we keep going, we'll watch something begins to become more coherent towards the end of this loop. But the main heavy precip was back before this system began to develop and move off to the east. And so if we could go back a couple clicks, we'll just go to, the start of Tuesday would be good. So one thing I picked up on is, so here's when the heavy precipitation begins to start over Oklahoma, Kansas, and if we could go 2 or 3 clicks forward, you'll notice we get pockets of very strongly positive vorticity and maybe slightly negative or weaker vorticity. And if we keep just clicking forward, you'll notice these pockets just appear and they persist. Maybe there's 1, 2, or 3 of them that develop, into distinct little features. And if we could go just back 2 clicks, it was a great time. So now we have 1, 2, 3 pockets where the gradient and vorticity just downstream of these would be very strong. So in order to force rise of motion, we would need the thermal wind to be blowing nearly zonal over these regions. So let's go back, and we'll just verify that. Right over Oklahoma, we can go to the, it was like hour 102 maybe? Maybe it was further. 114, let's try. I believe it was Tuesday at 9 UTC, so maybe a little back. Maybe like, let's go 108 would be good. And we can notice that's the case. We get this zonally oriented thermal wind with colder thickness to the north, so it's blowing from west to east. And this feature just persists. Like we get this baroclinic zone that just sits over the southeast. So you have thermal wind constantly blowing from west to east. You get those little pockets of vorticity. You have regions where you could have rising motion. And I think there was a time that I was specifically looking at that there were 3 distinct pockets that matched those 3 distinct strong gradients of vorticity that I was showing at 500. So that is one indication that you might have synoptic scale rising motion. And then if we go back to, we'll go to the 850 loop here, and we can just do the loop. And we'll stop it, and this is perfect, we can just step forward here. You'll notice there's persistent flow as the system just sits over western Texas. We could just keep going. You'll notice persistent flow from the Gulf out ahead of it, which is going to bring a lot of strong temperature advection and moisture advection sitting over the southeast. And this, the baroclinicity just sits there as the system moves, and you can notice in the heights it begins to move towards the southeast, but this just sits there. So you have synoptic scale motion, rise of motion, you have moisture and heat flux, 6-inch precipitotals over much of this region. Would be my best diagnosis of why we see these higher precipitotals. And the reason I point out Oklahoma and Kansas is in the last website I'll show. Can we go to the drought monitor page? It's I think it's in our Weather Watch links. Otherwise, it's droughtmonitor.unl.edu. The first one will probably get it to us. So this will show the current look at the drought. Yep. Where we have drought, and we can click on, we'll click on there first. You can notice a lot of southern Kansas is in exceptional drought, and this is about half the state that's sitting in this exceptional drought. And if we go back one click, also highlight Oklahoma. They unfortunately are split up in the regions. But like 1/5 of Oklahoma is in exceptional drought as well. So this signal where you have heavy precipitation over Oklahoma, Kansas, some parts of Texas, and then one place that I didn't point out, if we could go back one click, we'll just look at the full map here. The Northeast as well is in this heavy precipitation. So this is a good signal where you could maybe remove some of these drought-stricken areas slightly. But then much of where the heavy precipitation, there's no drought at all. So that will just be beneficial rain for agriculture. So yeah, that is all I had. Are there any questions or comments? Perfect. I will turn the baton over then.
Thanks, Patrick.
No, exactly.
Hello, everyone. So we wanted to talk about the chase we did the Tuesday after the March 31st tornado outbreak, and this was it was a privilege to chase this. Bella and I were in the same car with Isaac and Kaylin and Aaron and their friend Jonah. Anastasia was with her partner Cody, and Stephanie was with your husband, yes. And Anastasia and our car, we were in Illinois, about like the nose of Illinois, but Stephanie chased in Iowa, and we both saw some pretty cool stuff. So we're gonna explain why we were when we were. So here was the forecasted outlook. So this was why we went chasing, was because there was a moderate risk in this area. The northern and southern moderate risk, it was for all three modes of severe weather, so wind, hail, tornadoes, and the location of intensity of the storms were heavily correlated with the warm sector and the dry line, which we'll see on the surface maps. So this was the total storm report. So you can see there were a few tornadoes. There were some tornadoes. These were the ones that Bella, Anastasia, and I saw. And then Stephanie, you saw this one? Mm-hmm. Yes, okay. And then there were some north of us as well. Were those later on in the evening?
They were later in the day.
Yeah.
Because I remember them being active when we were farther south.
Yes.
There was no
Yes.
open catching us.
And then these ones in Missouri were later at night, and they also produced good amount of damage. Yes, and there was a good amount of hail as well, indicated by the green. What was you saw baseball?
Yeah.
You just
Drove past some baseball-sized hail.
Luckily you weren't in that.
No. We got very strategic with just trailing right underneath the hail water.
Yes, so, yes, that would have been scary. Yeah, next slide. So yeah, here was how it verified. As you can see, generally the reports fell within the slight risk range, but there's this little hole here, and what was that tied to?
So that's something we're going to touch on in the surface-based map. So I can actually click ahead and then come back to that to line them up. So based on this surface map, we can kind of notice that more over towards, I get the pointy stick now. So more over here towards Des Moines. This was earlier in the day compared to when we were looking at observations, but we could see a temperature of 81 over a dew point of 60. And that even got a little bit more exacerbated later in the day. I think when you were in Iowa, you said it was like 83 over 54. Right. So the dry air was really inhibiting a lot of the space within that south central Iowa. And another thing we noticed, especially on satellite and within the observations throughout the day, was that the warm front and the warm sector did not advect as far north as was anticipated throughout the models, and that really impacted a lot of the initiation within that area as well. Based on satellites, when we were looking and we were out, the clearing within this region of Iowa only went up to about like the bottom third of the state, and so that area got the most daytime heating, and so anything farther north that was anticipated to have more intense storms didn't actually end up happening. And so based on observations, probably like 3 o'clock, 4 o'clock, we decided to end you guys went a little bit before we did.
Yeah, that's when we started heading south.
Mm-hmm. We were a little bit behind them. We stuck around a little bit longer to see what the behavior in the area would be, but we ended up going more down towards this region where the max temperatures were a little bit lower, dew point stayed a little bit higher, and that ended up being the region where storms ended up initiating, especially the more intense ones, that the storm we were on, and we can kind of note that where those ingredients didn't really come together was a giant hole of where reports were versus where the risk actually was, and much of this hail and storm reports along this line right here ended up being convection and storms that were on the dry line a little bit later in the day rather than earlier in the day.
Yeah, you can see,
going back.
You can see the dry line here extending from Mexico all the way up to the low pressure center in Iowa. So that was when this eventually got to Missouri. That's when we saw that convection coming off the dry line.
Especially overnight, too.
Yeah.
All right, and we'll briefly touch on some of the upper air observations. So this one on the left is from 500 millibars at 12 UTC, so around 7 a.m. So you can, the main feature that we saw was just the main, like really broad trough across the western and continental United States. And there's also, we didn't put this on our slides, but if you looked at the 300 millibars for this exact time, there is an upper level jet that cuts through this same region. So right down in here was the core of that jet, and it was around, I want to say like 120 knots or so, and that just amplified throughout the day. Yeah, pretty high wind speeds. With the downstream side of the troughs, we're expecting to see our convection, so.
Upward vertical motion.
Yes.
aka by the thermal wind. So this is the 850 map as well from that day, and the green lines, I know it's really messy, but the green lines are dew point, and this was showing you like where exactly that dry line was. So on this side of the dry line, like the dew point here is 0. Oh my God, they're so hard to see. But over here, for example, these are closer to like, this is like 13, this is 11. There's one underneath that pressure value that I can't read, but I'm trying to explain that this was a very significant dry line, and that's why there was a lot of convection associated with it. So, brief overview. Here's some soundings. So this was taken at Lincoln at 20Z, and as we can see, there's a lot of Cape value associated with this, which is going to really help those updrafts. But at this time, so this was, our storms initiated around 0Z on the 5th. So there was still some SIN inhibiting that convection. There's a pretty significant hail parameter, as we can see by just how wide this updraft is, and like our freezing level is at 1,200 or 12,000 feet. So that's pretty crazy. There's some significant veering with height as well, as indicated by the photograph. If you go to the next slide. This was at Davenport at around the time of our storm's initiation. And yeah, this was when like the cap broke. This was also more north of the warmth route. Is that what we said?
Yeah.
Yes.
So especially because Lincoln is more that location is more towards central Illinois. That was more ahead of the dry line, a little bit more in that warm area with more elevated dew points, whereas this was kind of in that land of lesser values.
Yes. So yeah, this is pretty significant photograph with that too, really showing like the 0 to 6 kilometer winds per time.
Yeah, and having a really strong vertical wind shear is going to help with residence times for hail formation. So there was a good amount of hail associated with this event.
Yes.
So you can see that like really big Cape values, going to create a lot of positive buoyancy for hail to form.
Yes.
There's a bunch of stuff.
This is really something. Wow.
And here's some pictures that we took. Well, I took some of them, Isaac took some of them, so some iSlushy, ILMC photography. Yeah, so
And
these
then
were,
Anastasia's iPhone.
Yeah.
Just chilling.
So is this yours, Anastasia?
Yes,
Okay.
this is mine. We were on the opposite sides from each other.
Yes.
We were comparing Apple Maps and be like, oh, where were you guys when you took that? And we were just on opposite sides of the front edge of this storm as it was heading east.
Yeah.
this is from Industry?
Yes, this
Illinois?
is, we stopped here. Nothing eventually came fully down from this storm, but you can see the lowering right here. And then just like this massive wall of rain. This was our first like stop. We were like, what's gonna happen? Nothing happened with that. And then yeah, this
We
wall,
were probably about 15 minutes west of you guys.
yeah, that's what I would say too. And so yeah, this was Illinois. So we'll show some pictures from Stephanie's chase in Iowa later. But yeah, this wall of rain was
Wild. We took this from inside the car.
And like just this structure was just incredible, and how like it just spanned the entire sky, and we were just like right there underneath it. And yeah, another Isaac photo. The lightning
with
very
the storm
close.
was very intense,
Yeah.
very frequent,
Yes.
lots of CG lightning associated even through later hours, and hit a transformer at one point. Lit
Just
up
the cloud structure with this event was unreal to see, especially for me, someone who hasn't chased very often, and this isn't my forte. Getting to see stuff like this in the classroom into action was absolutely incredible.
Yeah, so this was when, right about when the Lewistown tornado dropped, and it was like just about getting covered by the rain, so we couldn't see it here, but you can see like just like these layers, and it was just like, it was like a cake. Like, they were just like so defined and structural, and then this was your photo.
Yeah, we were a little bit farther, still behind you, a little bit more northwest where you guys were stopped, but there was a pretty decent indicator of just like inflow band into the storm along the backside of just this general area with a lot of the rain curtains coming around the front. So you could just see how everything was congealing underneath the storm from our perspective, and we scooted back a couple times.
Yeah, I would have done the same thing.
That's a little bit zoomed in too. Cropping is our friend, but still, scooting is also plan of action.
Yeah, so I took these off my phone, so this, off Radar Scope, this is where we were relative to it, but you can just see this like signature hook echo, hail core probably right there, and then like the velocity couplet. It was, we couldn't see this tornado because it was rain wrapped, but it was, you know, it was significant, and like, yeah, this is just like textbook, so wanted to include that with that.
All right. I want to feel special. So this is Melcher, Dallas, Iowa, and the best way to describe this storm is it was a freak. It did not have the structure, the beauty of the storms in Illinois. Like when we first got here, it was just a big gray mass. It was just, the supercell itself was just not appealing to look at. However, it started to wrap up really quick, and then all of a sudden it just produced this tornado, which was odd. It was super high base, but also it's like coming out the side of the wall cloud there. Just about 6:10 or so, this is our location compared to the supercell. It had a nice hail spike on it. It was producing baseball-sized hail. And then about 40 minutes later is this right image here with, it just wrapped up really, really quick, and it just produced a tornado fairly quick after the warning was issued. And Pete, I do have a video.
Oh, yeah. Is it in my computer?
You can just bring up YouTube on your computer. but
Yeah.
I did have it on that.
Yeah. Oh wait, was it in my?
Yeah, it was in here.
Sorry, hold please.
That one.
It's a lot of pink on that screen.
It's a girl computer.
Wow.
And so this is a sped up version. And yeah, it was just a really beautiful tornado. It was mostly polite, but it did unfortunately do some damage to some homes. But overall, it's just in fields for the most part. So
You can just see it like rotating.
Yeah, you can.
Corkscrewing.
Yeah.
Yeah, that's pretty awesome.
It's so cool. The tilt is wild.
Yeah, it's on a mission in another direction.
yeah.
How long does this one last?
I think this was like it's on the ground like 15 miles. I think it was intermittent. So.
Okay, gotcha. Yes, very cool. So I think that's all we have. Any questions?
Very cool.
Comments?
Would you do it again?
Yes.
Yeah.
Now you would, right? You're 1 for 1. That's great.
I was just really happy to drive Bella the first chase ever that Friday before.
I'm a big snow and ice person.
was like
so that
driving
first chase,
a
we didn't see
kid on
tornado, we saw
Christmas.
massive hail, so I was
Yeah.
amped.
It was headache hail.
Yeah,
Bella
that
was
was
like,
We had our little AOS hail measure. Got to whip that
I
out.
saw
Put
that
it in
in
the
the picture,
use.
yeah.
That was pretty great.
Anastasia, what are you doing?
I was just closing it out.
Yes, that's all we have.
All
so-
right, thanks
Oh,
very
yeah,
much.
wait.
Are there a lot of storm chasers out there? Like, you run into traffic?
Yeah.
There was one point where we were ahead of a lot of people, my car, and so we were pulled over to the side of the road and just like watching the hail and taking a bunch of pictures. And there must have been a train of like 10 or more cars of just storm chasers all marching through.
There was a lot of
Wild.
chaser convergence in Illinois specifically, and that got a couple people in trouble. But I think that's the biggest thing too is like, I know that my partner and I, when we chase, we do have our spotter dots on, not only for us, but for everyone else on our radar scope. So then we can strategically pick routes as we are chasing to avoid where chaser convergence is, because it can be a really big problem. And even if you think you're okay, if everyone else also thinks they're fine, you can run into problems.
So we would stop at rest stops and we'd be checking out with like our cans of bubbler and stuff. And they'd be like, oh, are you guys out chasing today? Like, they know. It was wild.
Wow. It's a whole subculture with all these kind of
So interesting.
surveillance techniques now that are enabled by phones. It's really interesting.
Yeah.
I think that's a whole interesting story all by itself.
Yes.
But
Yeah, I know, like, we share our locations on, like, Apple Find My Friends or whatever, just in case, too, because it's like, even though we're in different cars, like, we're all out, and if we're in the same area, at
Yeah,
least I
yeah.
know, like, be like, hey, I haven't heard from them, I'm just gonna check and see where
There
their
was
dot
one
is.
point where I hadn't heard from you in a while, and I was like, Anastasia, and you were like, no, we're good.
I'm the driver, my boyfriend doesn't, like, really like the driving part, so I'm always the one driving, so if anyone else is also out and they're texting me and I don't answer, I always end up getting the phone call of, like, are you fine? And it's like, yeah.
It's definitely very silly to see a bunch of nerds on radar scope on their phones.
Yeah.
It's very
although it must have
fascinating.
made you feel at home.
Yeah.
If anything, it was nice to not chase by myself, because normally that's the case too. Like, I taught music, so it's not like I could go to my teacher friend and be like, hey, you want to go chase a tornado? And they'd be like, are you insane? So having other people to do it that, like, understand and, like, have a similar interest for it was kind of nice.
That's great. All right. I'm glad you had success and safety.
Yes.
Thanks a lot. Thank you, Pete.
Thanks, Pete.
Patrick, please, thanks. Severe Weather Awareness Week. We have a fake tornado warning at 1:45.